Exercise 1.1 Problem 11 Division 3 Solution. For set A equal to minus 3, 1, 0, etc. Set B equal to this much and set C equal to minus 1, 2, 3, etc. Verify using Venn diagram that A union B intersection C equal to A union B intersection A union C. Okay, so the key is they are asked, we did the same using our normal method. Okay, but now here they're asking us to solve it using Venn diagram. So when you have to do the Venn diagram, the key is before starting anything, you'll have to find A intersection B intersection C. Okay, that is one thing which you'll have to find. Next, you'll have to find A intersection B, then B intersection C, and then A intersection C. You have to list all these things, then only you'll be able to start working on the Venn diagram. Okay, right, now first step. So as I said, A intersection B intersection C. Okay, I have listed it here, but actually should have come in the front. So A intersection B intersection C, it is common to all the three, right? So you can just check it out. Minus 3, it is not in this set itself, so it doesn't go further. Okay. Okay, minus 1, it is here in B, it is in C also. So minus 1 will come inside A intersection B intersection C. Next is 0. 0 is not in B, so it won't go any further. 4, it is in set B and it is also in set C. Okay, so you can see 4 here and here, and minus 1. Okay, right. So 4 will also be part of the A intersection B intersection C. 6 is here in set B, but it is not in set C, so it will not get included. 8 is not in set B itself, so it won't get included. 10 is not in set B, so it won't get included. So A intersection B intersection C is minus 1, 4. Now next is, because you have to have A intersection B, B intersection C and A intersection C. Go by the same method and find out all these things. List it out. Okay, list out A intersection B, B intersection C and A intersection C. One I'll do. A intersection B, the same method. So between A and B. Minus 3, it's not in set B, so it will get dropped. Minus 1, yes, it is there, so it will get included in the set A intersection B. 0 is not in set B, so it will get dropped. 4, it is there, so it will get included. 6, yes, it will get included. 8 is not in set B, so it will get dropped. 10 is not in set B, it will get dropped. So A intersection B is minus 1, 4, 6. Similarly, find out B intersection C and A intersection C. Okay, and check your answer against these numbers. Now, to do this Venn diagram, what you'll have to do is we'll have to draw 3 circles, 3 intersecting circles representing A, B, and C. In the first circle, in the first set, we will highlight B intersection C. Then we will combine that with A and represent this. The whole thing will get represented A union B intersection C. Okay, in the second Venn diagram. Then we'll have to do one Venn diagram for A union B, one Venn diagram for A union C. Then using those two, you'll have to draw a Venn diagram representing A union B intersection A union C. Then you'll have to compare whatever result you're getting out of RHS and the Venn diagram which is representing the LHS. Are they both same? Okay, this is how broadly it will get done. Let's get going. Okay, so first one. Okay, so the first 3 intersecting circles representing A, B, and C. As I said, the first thing, now what do we want? We want B intersection to be represented because this is inside the bracket, right? So this is the first thing which you'll have to represent in the Venn diagram. So this is our first Venn diagram. Okay, so we'll have to represent B intersection C. But before getting into B intersection C, first fill up the area which is representing A intersection B intersection C. So this is the one which is representing A intersection B intersection C. Am I right? And what is our numbers? Minus 1 and 4. So put that minus 1 and 4 here. Next, B intersection C is what? This whole area, right? This whole area is B intersection C. And what is B intersection C? Minus 1, 3, 4 and 5. Out of which minus 1 and minus 4 we have already covered it here, right? Because that is also part of A intersection B intersection C. So now this area is purely B intersection C. But whereas this area is A intersection B intersection C, which is a part of B intersection C, but this area is only B intersection C. So the missing elements of 3 and 5 will come in this area. Now if you want to see B intersection C, you'll have to see this whole thing. See whether it comes right. Minus 1, 3, minus 1, 4, 3, 5. See, minus 1, 4, 3, 5. So B intersection is there. But all I'm saying is that don't put minus 1, 4, 3 in this area. This minus 1 and 4 is also a part of A intersection B intersection C. So first put A intersection B intersection C, and then whatever is left out in B intersection C, fill it up in this area, which is purely only B intersection C. Okay, but this whole thing is B intersection C, plus it also includes part of it is A intersection B intersection C. Okay, that is the key you'll have to understand in the Venn diagram. If you understand that correctly, then everything else will become very easy. So we have got the first Venn diagram, B intersection C. Next, we have to combine this with union, right? A union. So you'll have to unite this with A, and then you can draw one more Venn diagram. So that will represent the LHS. So now let's combine. So if you have to combine A, what will happen? You'll have to check all these elements. So 3 minus 3, it's not here. And okay, so before that, as I said, if you're putting A, so you'll have to put first this A intersection B area, then you'll have to put A intersection C area, and then whatever is left out is you have to fill it up here. Okay, so now what is A intersection B? A intersection B is minus 1, 4, 6. Minus 1 and 4 is already done, so you'll have to put 6 here, right, in this area. Next, A intersection C is minus 1 and 4. So there is not, both are covered here, so there is no element in this area. Then what you have to do in this set, you have to cancel out all these things, all these elements. Okay, so minus 1 is already taken care, 4 is already taken care, 6 is already taken care. So all the remaining elements you'll have to put in this area. Let's see how I've done that. So here we go, A union B intersection C. So first whatever is here, because it's union, right? So I'll have to first transfer this here, minus 1, 4, 3 and 5. So this is already come inside. Next, because now you want to combine with A. So this whole thing represents A. But this part of it is A intersection B. This part of it is A intersection C. So first you'll have to cover the intersection areas. Then only you will have to cover the pure A area. Okay. Right, now what is A intersection B? As I said, 1, 4, 6, but out of which 1 and 4 is already covered in the A intersection B intersection C. So what is left out? 6 is only left out, so you'll have to write 6 here. Now this area is A intersection C, right? So here A intersection C is minus 1 and 4. That is already covered in this minus A intersection B intersection C area. So there is nothing which needs to go in this area. Now you check your A. So now, so what all we have taken in this A, this is whole A, right? Minus 1, 4 and 6 is covered. Minus 1, 4 and 6 is also covered. Okay. So what is left out? Minus 3, write it here. Then 0, write it in this area. This area is purely A, that is, it is after deducting the A intersection B and removing A intersection C, whatever is left out here. Okay, so minus 3 comes down here, 8 will come down here, okay, 10 will come down here, and 0 will come down here. Now you check A altogether, is it represented correctly? So what is A? Minus 3, yes, it is represented. Minus 1, yes. Okay, this is A, right? So it is this minus 1 is also a part of A. So it is included. 0 is included. 4 here, this becomes a part of A. Okay, 6 is a part of A, correct? 8 is a part of A here, and 10 is also there. So we have done correctly. We have put all A together, but we have clearly put some of the elements in the area of A intersection B, some of the A, so there is no element in A intersection C here, and some elements are A intersection B intersection C. So we have put everything in the right place. So the key is first fill up A intersection B intersection C, then the two intersections A intersection B or B intersection C or A intersection C as and where it is applicable. Thereafter only you will have to fill up the remaining areas of A or B, these areas, or C. Okay, that is a key here. Anyway, now we have got the LHS done. Right. Now we'll have to start doing the RHS. What is our RHS? A union B. So start. A union B, as the first thing, as I said, this whole thing is there. Fill up, it's already there. We know the A intersection B, you can put this one here. A minus 1 and 4. And A intersection B is minus 1, 4, 6. Minus 1 and 4 is already covered in this. So 6 will go here because this area is A intersection B. Similarly, B intersection C. Next we'll have to see B intersection C. Because we are talking about A and B, right? So there will be A intersection B, B intersection C, and A intersection C. All three you'll have to be careful. In B intersection C, minus 1 and 4 is already covered here. And 3 and 5 will come in this area, because this whole thing is B intersection C, out of which minus 1, 4 is already covered in this A intersection B intersection C, and 3 and 5 will come here. Now intersection areas are done. This we know earlier itself, this is empty set. So A intersection, this is done, this is done, this is done, and this is done. Right, now what is left out is A. Actually you can copy this as it is, you don't need to do this at all. So 8, 10, 0, 3. So this will all come, right? Now all we need to do is we'll have to see B. In the B, minus 1 is covered, minus 2 is not covered, so we'll have to write here. 3 is covered here, 4 is covered here, and 5 is covered here. 6 is covered here. So minus 2 only is left out. So minus 2 will come in this area, because it's only whatever is left out is the pure B, which is not to do with anything and nothing to do with A and C. This is the area. Okay, so as I said, so shortcut is copy A as it is, A intersection B as it is, and B intersection C is also there, so that also you can copy. A intersection B also you can copy. Only thing you'll have to fill up this element, this area, which is basically whatever is in B, which is not covered by these numbers. Okay, so A union B. Next you'll have to do A union C. Same thing, copy your A as it is. A intersection B you can copy. B A intersection B. This is also can copy. This is A intersection B intersection C, right? And the B intersection C you can copy it down, and the remaining elements of A you can copy it from one of these actually. Okay, now what is it? A and C put together, right? Now you have to see, in C we have minus 1, 2, 3, 4, 5, 7, out of which minus 1 is covered. And then 4, okay, I'll just underline. So minus 1 is covered, 4 is covered, okay, here 3 and 5 is covered. Okay, so what is left out? 2 is left out and 7 is left out. So this whole thing represents C, out of which we have already taken minus 1, 4, 3 and 5. Left out is 2 and 7, so we'll have to fill it up here in this area. Okay, this is part of C which does not come under any intersection, but this is whole C. Okay, this is the thing which you have to understand clearly. This whole thing is C, but this area comes under B intersection C. This area comes into A intersection C. This area comes under A intersection B intersection C. But whereas this area does not come under any intersection. So that is why we'll have to separate it out. Okay, now we have done A union C also. Now what is the next step, RHS? You'll have to find the intersection of this and this. Now you see intersection. Is this common? Yes. So 6 is there. Okay. Now A intersection B intersection C is also there. 3 and 5 is also there. Minus 2 not there. So you'll have to take it off. Okay. Minus 3, 8, 10, 0, minus 8, 10, 0. So all these things will come because they both are there in both the things. So what you'll have to find? You'll have to find the elements which are common in both the Venn diagrams. But whereas 2 and 7, there's nothing here. So this will get dropped off, 2 and 7. Okay. So A union B intersections A union C, that is the common elements between these two Venn diagrams. If you can see, 2 and 7 is here in this Venn diagram, but it is not there. So that will get dropped. Similarly, minus 2 is here, minus 2 is not there, so that will also get dropped. But whereas the whole of A is here, so the whole of A will come here. And this area 3 and 5, which is a part of B intersection C, is in both the cases, so that will also come here. So this is what represents A union B intersection A union C. Okay, But now take a look at this and this. You see, both are the same. It represents A and it represents part of B intersection C. Am I right? So both are equal. So as can be seen from this division 2 and division 5, the two Venn diagrams, A union B intersection C equal to A union B intersection A union C. Okay. So this is how we'll have to do the Venn diagram. Let me repeat. So first step is you'll have to find the A intersection B intersection C and the three other intersections, A intersection B, B intersection C and A intersection C. Then first fill A intersection A intersection B intersection C. Then fill either A intersection B or B intersection C or A intersection C, depending upon the case. After filling all the intersections only, you'll have to go for the pure A elements or B or C elements. Okay, that's the only trick we'll have to follow in the case of Venn diagram. I hope it's clear. Please try it out on your own. It will become easy. Thanks for watching this video.